derivative of function y with respect to x, which tells us immediately that y is a function of x. Okay, so we differentiate implicitly. And we have a function that is applied to a product. So we have the chain rule and the product rule in there. So I differentiate cosine of this argument, whatever that is, so I get negative sine xy times, and now I have to use the product rule, and I will have two terms. Every time we apply the product rule, we have to get a sum of two terms. It could end up in a difference, but that's still a sum of two terms initially. The first function prime is 1 times y plus the first function times the second function prime. But y is a function, so I have to write dy over dx equals. I differentiate 1, which is 0, but when I differentiate sine, I get cosine y, but y is a function. It's not just a plain variable. So this will be dy over dx. Any questions? Is this okay?
Can you do the first part?
Yes.
Explain the...
Yes. So just assume you have a variable in here. So when I differentiate cosine, I get negative sine of the same variable. But it happens that this is not a variable. If this were cosine x, I would have be done with negative sine x. But this is a product. So I differentiate the outer function, and now I have to differentiate the inner function. But the inner function being a product, when I differentiate using the product rule, I have to get two terms.
Yeah.
So I differentiate x and I get 1. X is the variable. It's a variable. So and then I copy the second function plus. I copy the first function, and now I have to differentiate the second one.
And that's because we're looking for y with respect to x. That's why.
Because we're differentiating the product. So this is function 1, and this is function 2. So the first function prime is 1 times the second one, and then plus. I copy the first, and I multiply by the second function prime, which is this. Because it's a function that I don't have.
Okay. So the derivative of y is dy over dx?
Yes. So then I differentiate 1 and I get 0, and I differentiate sine of a function. If this were just a variable, I would have been done with cosine x. But I differentiate the outer function, I have to differentiate the inner function. Now I have to distribute this piece to these two terms. So I put y in front, negative y sine xy minus x sine xy times dy over dx. I had to distribute this quantity to both terms. And the right hand side is cosine y dy over dx. Is this okay? I only distributed this factor to y and the same factor to this piece. So this times this is here, and x times this times dy is here. Now there are two terms with dy over dx, and they have to be on the same side. So I have negative y sine xy equals. I see these two are the same, right? So this is what I'm after, dy over dx. And then I get x sine xy plus cosine y. After I factor out. Is this okay?
What did you do at the last part?
I moved this term to the other side, and I also factored out dy over dx.
Oh,
This is here.
So you can factor it out.
I have to, because there are two terms that are not like terms. I can't combine them. I'm trying to solve for this, but I can't combine them. They're not like terms. So these two have the same variable, so I pull out the variable that I'm interested in. Is that okay? Okay, so finally we divide this by this. So dy over dx equals y sine xy divided by x sine xy plus cosine y. And that is final.
Now, how would this be used in a,
Um,
rate problem?
Yes, so like in applications,
Yeah,
when you get to Calc 2 and engineering, for example, or physics, a lot of situations we cannot solve for the function. We don't have y equals for the function itself, or we can solve it. So, for example, this equation you can try, but you will never be able to solve the given equation for y. But we may still be interested in the rate of change of y with respect to x, and this is it. This gives us the rate of change. Yes, this is the derivative and it gives us the rate of change. Yes, Noah.
Will we ever have to take second derivative?
That will be a killer.
Tell me what?
It will be a killer.
Well, that version of the.
Yeah, let's do that. Let's look at an application with that, but something more decent, because that would be. Okay, ready? Would you like to choose, or I can? Okay, so here it is. Let's take a look. And implicit differentiation. After the chain rule. Okay, here it is. So we can be asked to determine something like this, right? Find the second derivative by implicit differentiation. So we can choose any of these. Of course, the ones with radicals will take longer, but that's fine, whatever you want to choose.
it's 37, pretty good.
Yeah, that's fine. Whatever that is, sure. I don't know what we will end up to for the second derivative. So x to the third plus y to the third equals 1. So this is 37 on page 215. So always remember, this is a function, right? So y is the function of x. Once we're asked to find dy over dx, we know that y is the function. So we will differentiate implicitly, and we will get 3x squared plus 3y squared dy over dx equals 0. It doesn't look too bad. So dy over dx is negative x squared over y squared. Not too bad so far. Okay. So then the next step would be to differentiate again. So I moved 3x squared to the other side, becomes negative, and I divide by 3y squared, and I get this. So this is the first derivative. But now what we really are looking for is the second derivative. So I'll differentiate this side, and I'll differentiate this side. Although you could say, just simplify by 3 here, and it's easier to differentiate that. So it's up to you. I let you decide. You can say, that's good. So you solve for dy over dx is negative x squared over y squared. That's perfect. But it's better and easier to go back to the original of the divide by 3, which makes no difference, and differentiate this instead of differentiating the ratio, where the function is in the denominator. So let's differentiate that. It doesn't matter. So if I differentiate this and this, I get 2x plus. Now remember, this is a product. So I have to get a sum of 2 terms. When I differentiate the function, I get 2y dy over dx times dy over dx, which is dy over dx squared. One more time. When I differentiate y squared, I get 2 times y times dy over dx times dy over dx, which is dy over dx squared, plus y squared. And when I differentiate the first derivative, I get d2y over dx2. When I differentiate 0, I get 0. So this equation, I need to solve this equation for d2y over dx2. I would replace this by that squared. So finally we get d2y, or the second derivative, over dx2, is definitely divided by y squared. I move this to the other side, put the negative for both of them in front, 2x and plus 2y times x to the fourth over y to the fourth. Let's do this one more time together. So I have to divide, so after I move these two terms to the other side, I will divide by y squared. What do I have at the top? Both will become negative, so I put the negative in front. So 2x plus 2y, but now this is dy over dx squared. It's a negative, but when I square, I get positive, x to the fourth over y to the fourth, instead of dy over dx squared. So now I try to simplify it a little bit. d2y dx2, we'll simplify by y. I will take a 2 outside, and I have x plus x to the third over y cubed over y squared, or negative 2 x y cubed plus x cubed over y to the fifth. I'm very particular about everything to be lined up, but it's not lined up. So I will have to write it one more time. Fraction line, equal symbol, negative 2, fraction line, all have to be on the same line. So xy cubed plus x cubed over y to the fifth. So this is okay, but it's not perfect. It's not correctly lined up. Yes, Greg, go ahead.
Can we do number 2 on test 1?
Yes, is this clear?
Yes.
Okay, number 2 from what?
Test 1.
So we go back to test 1?
Yeah.
Very good. So let's go back to test 1. Okay, which one? You said number 2?
Yeah, we test 1. Actually, yeah, I would like to do that one.
Okay. So in this one, we are given a point p comma 9, p 9 comma negative 3, and we are given the function which is 3 over 8 minus x. And of course, the point q will be x comma 3 over 8 minus x. Okay, I copied it. And they want us to determine the slope of the secant line PQ. So I'll determine the slope of the line PQ will be 3 over 8 minus x minus plus 3 over x minus 9. And they want us to determine, so create a table. So I will put this, whatever you see, directly in the graphing calculator. So let's go to y equals.
I have a question.
Yes?
How did we, so is y given to us, the y equals 3 over 8 minus x?
That's the function, yes. Yeah.
Then how do we get the plus 3?
Because it's minus 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 3.
Okay.
y2 minus y1 over x2 minus x1.
Oh.
Right? So the function, the q is the point x comma the function, and the point p is 9 comma negative 3. So when you plug in 9, 8 minus 9 would be -1. 3 divided by -1, you get this point.
Oh, we're using pink here. Okay.
Right, right.
Okay, gotcha.
So once I have that, I go to y equals. And in y equals, I plug in this particular function. In parentheses, be very careful with parentheses here. 3 divided by, in parentheses, 8 minus x. And then plus 3 outside. And close the parentheses. And you divide in parentheses by x minus 9.
And then you just type in the corresponding values.
And then I get closer and closer to 9. I cannot plug in 9 because it will be undefined, right? So I go to second and table, and I plug in 9.1. I plug in 9.01. I plug in 9.000001. And I can go from the other side with 8.9, with 8.99999, and 8.9999999. And I will determine the slope of the tangent line at P. Yes?
Are we using these methods?
We are not determining solutions here. We're determining the slope of a line, of the tangent line to the graph.
Okay.
So we are not, this is just a slope, it's just a ratio. We're plugging in numbers in the ratio, but we are not solving an equation. So then I will write that as x approaches 9, the slope of PQ approaches the slope of the tangent at P, which is 3. Is that better?
Yeah.
Okay. Yes?
For the test 1, chapter 2,
Yes?
we have to find the derivative of a function using the definition of the derivative.
Yes?
Can we do that?
Yes. Any function. Just give me any function you want.
I guess the 4x plus 1 divided by
Okay, so f of x, 4x plus 1 divided by
x plus 3.
x plus 3. Good. So f prime of x, we know it's the limit as h approaches 0 from f of x plus h minus f of x divided by h. This is the definition of the derivative using the definition, right? I mean the definition of the derivative, not the definition of a derivative at a value. We have two, or at a number. We have two definitions for that.
Right.
But for the actual derivative function, we only have one. Okay, so let's continue. I will plug it in. So I have limit as h approaches 0 from 4 x plus h plus 1 over x plus h plus 3 minus 4x plus 1 over x plus 3 and everything divided by h. Is that okay?
That's when you do the, where you multiply it out.
Yes. So then we have limit as h approaches 0. You should always find the derivative, right? Because now you know f prime of x, the top prime is 4 times x plus 3 minus 4x minus 1 divided by x plus 3 squared. So you can immediately find that using the quotient rule, right? So you have 4x minus 4x is 0, so this is 12 minus 1, 11. So you know exactly what to expect already. Okay, so then we continue with multiplying this by x plus 3 and multiplying this by x plus h plus 3, correct? And then h, I can already bring the denominator down. So careful how you multiply, because this is 4x plus 4h plus 1. X times 4x, 4x squared. X times 4h, 4xh. X times 1. 3 times 4x, 12x. And 3 times 4h, plus 12h, and then plus 3. And you know, with these, I always run out of room. Sorry about that. So now everything will be negative. So negative 4x squared minus 4xh minus 12x minus x minus h and minus 3. And you always know what has to happen here. What has to happen? Terms without h must go away. So then we eventually factor out h and simplify h also. Okay, so the 4x squared with a positive, the negative with positive, the negative 12x with positive 12x, the negative 3 with positive 3, the negative x with positive x. And the numerator has only these two left. So limit as h approaches 0, 11h divided by h, x plus 3, x plus h plus 3. These two go away. So this is indeed 11 over x plus 3 squared as expected.
We still have to know how to do all this, right?
Yes,
prove that,
please.
to prove that.
Yes. Yes, please.
And for the top one, for number 1,
Yes?
did we just plug in 0?
Where should I look?
The one right above it. The limit as x approaches 0 to the right.
Yes, it's the same thing. Yes, it's the same thing. You're finding the slope. And you just plug in numbers left and right of 2.
Of
In
2.
this case, only from the right, but you can also plug in from the left to convince yourself that the answer is negative 19.
And we're going to have problems like number 4 on test 1, where we have to make our little x and f of x. And
Number 4 in test 1.
chapter 2. Yeah.
Oh, you mean chapter 2?
Chapter 2, I'm sorry.
What am I doing? Okay, sorry. So this was chapter 1, right?
Right.
This was test 1. You want me to go back to test 2?
Yes.
Okay. One more time, number
4.
number 4. This one?
Yeah, it says test 1, chapter 2.
Okay, so we're talking about test 1.
Yeah, test. Yeah, test.
That's
1,
okay.
chapter 2.
That's okay.
And it said it's estimates.
Trust me, I know what everyone is tired.
Yeah.
It's the end of the semester, so we want test 1.
Test 1,
Okay.
number 4, where we have to present the graph of a function to satisfy conditions. I don't know. Maybe this is a different. Yeah, I got them up there.
Yes. Yes. So let's do that. All you have to do is just summarize the information in a table, and then you'll have no
Okay.
difficulties. Yeah. So let's do that. Can I keep it for a second?
Sorry.
I truly believe so. I will not take credit. So, you mean in the book?
No, my teacher last year used to make like a line and then put tick marks and your critical numbers and then like this is plus, this is minus, this is plus.
Was it easier than what I showed?
No.
No, this is, because I had to do the same thing, and this is a lot better.
It's only because you have everything condensed in one piece. And then they will all, first of all, you check.
And it's not just everywhere.
Right, it's not everywhere and it's condensed, and you can always check, remember? That's how I find my mistakes. if the sign of the derivative does not work with the values that I get for the function, I'll say, whoops, how can it be increasing if the values go down, right? Or vice versa, correct. Okay, so here's what I recommend here. So the limit from the left of f of x is of negative 3, so here's negative 3, and the limit from the left, they say, is 2. Of course. You can tell it's the end of the semester, right? I mean, I'm all over the place. Okay, so negative 3 from the left is 2. Negative 3 from the right is 0. So I took care of this and of this. As x, the limit of f of x as x approaches 2 from both sides is infinity. Done. The limit of f of x as x approaches 5 from the right is infinity. 5 from the left is negative infinity. Limit as x approaches negative infinity is 0. Done. And the limit as f of x approaches, as x approaches infinity from f of x is 0. And f of 0 is 0. So, here are my conclusions for now, that this is a vertical asymptote, this is a vertical asymptote, and y equals 0 is a horizontal asymptote both sides. Here you can make it defined if you want or not. It's up to you. Doesn't matter. So I have to graph the asymptotes first. At 2, at 5, and y equals 0. This is an overkill, but I'm going to write it. So at negative 3 is 2 on the left and 0 on the right, and it approaches 0. Approaching 0 at negative 3 is 2. You can make a full point here, you can make a full point here, or nowhere. It's up to you. You can add on whatever you want. So 0, 0, okay, fine. And it goes to infinity. So at negative 3, 0. And it crosses the origin and goes to infinity on this side. On this side is negative infinity and then goes to a negative infinity. Fine, okay. Positive infinity on the right hand side of 2, but negative infinity on the left hand side of 5. And then from positive infinity to 0, very clear. This is not the only answer. This is not the only correct answer.
So
You can come up with so many other options.
for 2, on the left and right, it's approaching infinity.
Yes.
So it's a vertical asymptote. And also for 5, it goes from negative.
Yeah, because vertical asymptotes can have this, or this, or this, or this. It's still a vertical asymptote.
So as long as it's an infinity on each side?
Even if it's just one.
Oh, even if it's just one?
Yes, it could be like this.
Oh.
It's still a vertical asymptote.
Gotcha.
At least one side.
At least one side.
At least, yes. One. Yes, Eddie?
Could we do another problem? Could you do one logarithmic or two,
With what type?
using natural log?
Are we looking for max min? Are we looking for just differentiation?
Yeah, I just wanted to see that rule again in a problem.
Okay, so do you want to choose? So let's go and choose from. This is still in chapter 3.
Or could we do it with using log, using the limits? How we did that?
Oh yeah, so you want to use L'Hopital's rule with something like that?
Yeah.
Okay, perfect. L'Hopital's rule in 4.4. So see if you find something you're looking for. So something with a base that is not E.
With 24, if you consider.
24 has base E.
Oh, it has E.
So here's one.
It's like it's
Is that what you meant?
Yeah, that looks good, yeah.
Okay, so let's take a look. So this is 31 on page 308. Limit Sx approaches 0. X 3 to the x over 3 to the x minus 1. Okay, ready? So I plug in 0 and I get 0 over 0. Would you accept that?
sure.
Right? Because 3 raised to 0 is 1, but 1 times 0 is 0, and then 1 minus 1 is 0. Agreed? So we can apply L'Hopital's rule. So limit Sx approaches 0. Now, careful with the numerator. The denominator is easy. When I differentiate 3 to the x, remember it's 3 to the x times natural log 3. Always refer back to e to the x. When you differentiate e to the x, you don't need natural log e. But if the base is anything else but e, you'll have to remember that natural log. Is that okay? Now the top is a product, so I have to deal with it as a product. I have to differentiate as a product. The first function prime is 1 times 3 to the x plus x times the second function prime, which is still 3 to the x times natural log 3. Is that okay? Okay, obviously I see that I can pull out 3 to the x. And what is left in parentheses is 1 plus x natural log 3. And the denominator 3 to the x natural log 3. Because I saw this. I saw the top and bottom have a common factor of 3 to the x. And now when I plug in 0, what do I get as the final answer?
1 over. We have run like this one test.
Say it again? Yes, we did.
Like another string rule like that. Like this one, because this one's like a to the u equals a u ln a. It's like another.
Because if we have any, like 3 raised to a function of x, and we need to differentiate, I have 3 raised to the function times the function prime, and I would have stopped if this were e, but it's not e.
There's like 4 special cases like that. Like there's a log one too, isn't there?
Right, so yes, so if you have
Log base.
log base 2 of x, remember this is natural log x over natural log 2. So you never have to really differentiate this, but just remember the change of base formula. So when you differentiate this, you will differentiate that, which will be 1 over x natural log 2. You don't have to memorize this one, as long as you remember the change of base formula. Yes?
How do we do, I think we have to differentiate. Is that just the 1 over x?
Yeah, this differentiate. So tangent inverse of 8x. And this is squared, right?
Yeah.
Okay, so we are differentiating the function squared. So when I differentiate this, I get, first of all, I bring 2 down. I subtract 1 from the power, and I get 1, times tangent inverse, which is 1 over 1 plus 8x everything squared, times the inner function prime, which is 8. So this will be a 16 over 1 plus 64x squared, and multiplied by tangent inverse of 8x. Well, I wish you happy Thanksgiving. Don't drink and drive. I have to say it.
For the chapter 3,
Yes?
I think in the practice test there was the gravel. Is
Yes, the cone.
that- yeah. Should we look over the videos or more?
We can work on that, on other problems in class.
For the test, we don't have to know like the arctan of secant and cosecant.
The derivative of arctan. Yes,
For-
but not just arcsine, cosine, and tangent.
Gotcha.
These are the most, if I put anything else, I'll give you the formula, which I don't. I'm testing the basic understanding of all this.
Those kind of like absolute values in there.
No,
Should we spend as much time on the science studying it in the test?
no, it's just, you know, I looked at the WebAssign, but what we covered in class, nothing else. Everything was done, everything was done in class. But yes, you have to finish your WebAssign,
Yeah.
just in
Right,
case,
right,
so
yeah.
you don't wanna have any surprises.
Okay.
Thank you.
Next Tuesday is the test, right?
Next Tuesday is the test.
Because I think our tests included using some web design and stuff like that. So it's-
Yes, but we covered all of them in class, but
Yeah.
yes, but that's why I don't want you to leave anything unturned,
Okay.
yeah. No stone unturned.
And we'll be in the class for fun.
Yes, yes.
For the test 4, I know we went over it in class. Is there any like pre-written or just like, that when we were reviewing something?
Have a great
You
Thanksgiving.
too, thank you, thank you. Say it again?
For, you know how when we were reviewing for test 4
Yes,
for the packet,
yes.
was the only solutions done in the video or was there something?
Oh, I didn't post anything, yeah.
Okay. Thanks for being such a big help for me this year.
Anytime,
Appreciate it.
anytime. My pleasure. If I can help, I'll always do it.
I I grew up as an English guy,
Yes,
so like
so
I
you
could-
changed into math guy.
I don't know how I'm feeling about it. Like when I was in high school, I was getting 7 and 8s on my AP English papers, like nothing, but it was always math we were struggling. So then